Hello everyone, welcome to another Wave-to-Wave webinar, which is part of our series on automated fiber switching technology and applications. Please have a look at our entire webinar lineup to get the full overview of beneficial impacts of automated fiber switching in various deployment scenarios. Today we will focus on mobile network operators, or MNOs, and the strategic directions they are undertaking to satisfy the rapid demands for their services. Legacy MNO infrastructures are built with proprietary vertically integrated network elements, leading to inefficient utilization of network resources. In addition, it is very difficult to customize the current infrastructure for different wireless customer needs or locations. To that end, the wireless industry has developed the Central Office Re-Architect as a Data Center, or CORD, reference architecture to evolve the current mobile communications infrastructure into a data center-centric model to achieve cloud-style economies of scale and agility. Next slide, please. We'll start with a quick look at CORD use cases, ecosystem drivers, various architectural components, and the reason CORD is considered the solution to MNO service delivery needs. This is followed by an overview of the Centralized Radio Access Network, or C-RAN, virtual baseband digital unit architecture. We will show how MCORD satisfies both C-RAN and data center virtualization approaches. We will also touch on MCORD implementations and deployments. Once we have reviewed implementation approaches, we will look at integrating AFS products into C-RAN, MCORD front-haul network deployments. Here we will look deeper at utilizing AFS products to support WDM-PON mobile front-haul networks, as well as software-defined radios, or SDRs, based on digital units, or DUs. We will also briefly touch on using AFS to enable MCORD outside plant fiber cable testing. We'll conclude with a discussion on the value proposition of integrating AFS products into the MCORD ecosystem. So let's get started. Next slide, please. The goal of CORD is not only to replace legacy network elements with more agile counterparts, but to also enable the network operators to quickly support more attractive and meaningful services. The idea is to re-architect network equipment bundles to support virtual instantaneous reformulation of infrastructure needs based on new service requirements. That way, the use case applications define the network service. To support this evolution, CORD has a number of primary use cases, including RCORD, which defines the architecture for residential broadband, MCORD, which defines the architecture of the radio access network and evolved packet core of LTE 5G networks, and eCORD, which defines the architecture of enterprise services such as Ethernet business services. Although not specifically called out here, other use cases include C-CORD, which is a wave-to-wave suggested architecture to define cable operator MSO architectures, and A-CORD for analytics that addresses all four use cases and provides a common analytical framework for a variety of network management and marketing purposes. MCORD is considered the most pressing opportunity for OpEx and CapEx reductions from a network technology deployment perspective, simply due to the explosive growth of mobile services. Next slide, please. Since the introduction of smart devices and exponential growth of data traffic, mobile operators have faced challenges in attempting to densify networks, increase efficiency, improve user experience, and capture additional profitable opportunities. This is especially important during slow revenue growth due to competitive pressures. They have attempted to keep up with market pressures by spectrum investments and deploying new generation of network technologies and architectures at an accelerated pace, from 2G to 3G to LTE and now 5G with RANs. The exponential increase in mobile data traffic over the past few years has been astounding, and this trend is still strong, with global mobile traffic expected to grow by a factor of 8x from 2015 to 2020. Also, densification is an acute challenge from an OpEx and CapEx perspective, but it also presents tremendous opportunities for MNOs with respect to revenue potential. The world is going mobile, and MNOs have a great opportunity to create new business models if ideal ecosystem components are utilized to their full potential. CORD is the architectural means for MNOs to achieve network stability while keeping up with service demands that are driven by diverse devices and increase in wireless data traffic. Next slide, please. MCORD targets mobility networks and focuses on developing the economies of a data center approach for MNOs. It specifies how network element functions can be aggregated or disaggregated with instantiation on commodity infrastructures to reduce CapEx costs. The goal of MCORD is not only to replace legacy network elements with more agile counterparts, but to also enable the mobile network to quickly support more attractive and meaningful mobile services. MCORD transforms the traditional mobile network architecture, decoupling control and data planes. This allows the decoupling of services creation from the underlying vendor-specific hardware. However, the immediate cutover to a virtualized cloud-style agile operations environment would be far too expensive to roll out with entirely new equipment on day one. MNOs need to be able to economically and flexibly utilize existing equipment while simultaneously and expeditiously extending mobile network capabilities. This drives the selection of architectural components for real-world core deployments. Next slide, please. MCORD achieves the forward direction with a reference architecture solution that is built on the pillars of software-defined networking, or SDN, network function virtualization, or NFV, and cloud technologies. This is in stark contrast to legacy 50-year-old COs that contain hundreds of various equipment types to procure, operate, and manage. MCORD is an ideal rapid innovation platform towards 5G networks, since emerging 5G networks must not only support increasing data rates, but also support a common infrastructure where new wireless services are based on vastly different network QoS requirements. To address such needs, a 5G architecture needs the ability to dynamically create programmable virtual networks and differentiate traffic treatment utilizing solutions based on network slicing. MCORD leverages open source software, disaggregation of network elements, along with centralization and virtualization of RAN components, in addition to other core functions of mobile wireless networks. Next slide, please. When we speak of C-RAN, it has several quote-unquote C characteristics: centralization, collaborative radio, clean system, and cloud computing. We centralize several base stations to a central baseband digital unit, or DU, processing pool, and use real-time cloud computing techniques to process different radio standards. The distributed remote radio units, or RRUs, collaborate with each other to reduce interference for a clean system operation. A C-RAN architecture with the proper ecosystem components, such as AFS, can also support placing baseband DUs in a virtual processing pool while simultaneously supporting data exchange. Next slide, please. MCORD is influenced by emerging C-RAN and 5G standards. It specifies how mobile network element functions can be aggregated or disaggregated with instantiation on commodity-based infrastructure to reduce costs. The goal of MCORD is not only to replace legacy network elements with more agile and virtualized counterparts, but to also enable the mobile network to quickly support more attractive and meaningful mobile edge services. Network slicing utilizes MCORD's key features of disaggregated virtualized RAN and evolved packet core components, along with open source implementations for RAN that allows customization and modification. It is anticipated that the EPC core network will migrate to the cloud, and the user plane of the EPC core network will use SDN-based switches and routers with extended functions. This SDN architectural approach, integrated with an AFS, can enable MNO business model transformation possibilities, such as base station virtual resource rental models or cellular infrastructure and intellectual property agencies, along with more premium mobile services. Next slide, please. MCORD implementation with centralized baseband processing DU nodes provide an on-demand allocation of computation processing resources. The front haul network connects the CO BBU DU pool with geographically dispersed RRUs. Information is exchanged between the RRU and the DU BBU pool over the front haul access distribution network. The goal of decoupling baseband processing from the RRUs is to enhance redundancy and maximize operational reliability of the DU pool. The front haul network communication protocol standard between the centralized BBU DU pool and RRUs is based on the Common Public Radio Interface, or CPRI, specification. To manage the connected radios, the BBU uses the front hall CPRI standard to transfer synchronization, radio signals, and control and management signaling. The best facility for the front hall CPRI is dark fiber because encapsulating CPRI in another protocol introduces too much latency and jitter to comply with the specification. When exploring options for front hall solutions, it is important to consider the typical implementation for sites in densely populated urban areas. In this urban area scenario, we estimate that 2 out of 3 radio sites have access to fiber front hall networks. Next slide, please. To facilitate dynamic scheduling of computational and accelerator resources for virtual DUs, an efficient topology reconfiguration approach for fiber interconnects is needed amongst DUs in the same and different racks. This requires a flexibility point between the DU MUX and baseband DU equipment, regardless of whether it's VM-based or traditional dedicated specific equipment DUs. This infrastructure provides a software-defined Layer 1 switching capability that allows the cross-connect management process to be automated. In addition, the integration of an AFS unit with DU equipment redundancy could provide backup DUs in a real-time way. A scale of several dozen or several hundred RRUs require many fibers for fiber connections to DUs. As the number of streams on a single fiber pair increases, it becomes more important to have geographical redundancy and protection in case of a fiber cut. Therefore, it is important that a front hall solution provide backup mechanism in case of fiber failure. Having an AFS that enables the flexibility in deployments to support the required reliability requirements, regardless of DU equipment design, is ideal. Next slide, please. Turning our attention to the front hall network, if an area has limited access fiber or rental wavelengths, wave division multiplexing or WDM is an option, as well as passive optical networks or PONs. WDM and PON technologies create new possibilities for a cost-effective convergence with M-Cord because a high number of CPRI signals can be transported into a smaller number of fiber cables using wavelengths and PONs instead of dedicated fiber links. Also, fiber interconnects enable DU nodes to be placed in the same room, floor, or building to form a DU hotel. In this way, C-RAN M-Cord could facilitate implementation of collaborative wireless radio networks to reduce interference as well as improve system performance. The downside of WDM is there is no one-for-N interface protection, and scaling to hundreds of front hall CPRI links becomes an operational challenge without AFS components, such as seen here with the Roam 500 product. AFS integration into the front hall termination deployment enables the protection scheme economically, efficiently, and quickly. Next slide, please. The emerging M-Cord SDN C-RAN model is to spin up the software-defined radio DU-VM resources based on the optical interface on a given port. This approach enables load balancing and scalability to be achieved through virtualization, which reduces waste of computational equipment resources. This solution is ideal to support the evolution of MNOs to a cloud-based data center architecture model. Another objective of C-RAN deployments is dynamic task and load migration. C-RAN M-Cord adopts general-purpose processors to replace conventional closed hardware baseband DUs. Each type of baseband signal is processed through SDR DUs based on a virtual machine or VM platform. With virtualization, VMs could be treated as an independent operating environment with virtually independent CPU and I/O resources. Next slide, please. C-RAN M-Cord equipment integrated with AFS products makes expensive radio and processing equipment more effectively shared, reducing capital and operational expenditures. For example, increasing the size of the C-RAN DU cloud makes it difficult to switch data from an arbitrary RRU to any DU without an AFS. When the size of a C-RAN reaches a certain level, for example, more than 30 sectors, the resource sharing gain may become flat or marginal. Therefore, it's not economical to design a high-speed, non-blocking mesh DU cloud with no flexibility fabric. In addition, when increasing cloud size, MNOs can install more BBU DU clusters or upgrade clusters faster than with outdated manual fiber patch panels and cross-connect processes and procedures. AFS co-located with centralized BBU-DUs provide equipment pooling gain to more efficiently utilize BBU-DU equipment and reduce capital costs. This means that BBU-DUs whose CPRI ports were only partly filled from a cell tower site can be fully utilized at the CO. Therefore, the same number of cells can be supported by a fewer number of centralized BBU-DUs. Next slide, please. MNOs must also rapidly detect, identify, and resolve service impairments. Providing test and assurance functions as a business model service can be chained with other network services SLA models. These test and assurance services can then be used in real time to drive root cause analysis and enable closed-loop automation of network control to improve the network's behavior and help reliably deliver new SLA-based services. Use of AFS enables MCORD to instantiate test and monitoring agents. For example, an AFS providing protection switching and centralized remote outside plant cable testing can address the needs of MNOs managing real-world MCORD networks. MNOs can use AFS products for testing multiple RAN fiber front haul networks with the same OTDR, using an AFS to select the fiber path to be tested. This approach enables a single OTDR to handle testing for an entire CO. With an AFS, the Network Operations Center can remotely test facilities from the NOC, enabling them to troubleshoot before sending technicians to remote tower locations. Expensive OTDR test equipment can be centrally located, readily available, and shared over multiple fiber facilities. AFS can therefore save many hours of mobile network downtime and help MNOs to more effectively honor SLAs. Next slide, please. As we have seen, AFS technology can offer powerful operational benefits when integrated with MCORD deployments, including faster time to revenue, transformation of the MNO business model, dynamically scaled MCORD BBU-DUs, remote testing and troubleshooting of front haul network facilities, and minimize downtime and fewer outages. AFS will enable MNOs to minimize labor, eliminate mismatches resulting from human error, optimize CapEx, and facilitate testing and maintenance of their MCORD deployments. Last slide, please. So in summary, MCORD focuses on centralization to aggregate different BBU-DUs as NFVs, along with SDN and cloud technologies. The emerging MNO SDN model is to spin up SDR BBU-DU VM resources based on the fiber interface at a given physical port. MNOs can gain the OpEx savings benefits immediately with AFS while simultaneously pre-positioning the mobile network for future MCORD evolution. Without AFS, they run the risk of seeing their costs quickly spiraling out of control and making it harder to pre-position the network for future MCORD evolution, which adds more pressure to already tight profit margins. Finally, the MCORD architecture approach integrated with an AFS can enable MNO business model transformation possibilities, since the cloud concept would generate new business opportunities such as an equipment pool virtual resource rental system of cellular infrastructure or an intellectual property agencies or premium mobile services. So in closing, we want to thank you for joining us today, and we look forward to seeing you on another Wave-to-Wave webinar in our series. And please, feel free to send any questions you may have to info@wavetowave.com. Have a great day and see you soon.